Number 7, row 2. In order to change 5 squared to the third power, I could apply my rules of power to a power, which say that if I take a power, like 5 squared, and raise it to another power, like to the third power, I just multiply those powers. So that gives me 5 to the 2 times 3, or in other words, 5 to the 6th power. For a better explanation of why this works, what I'm really doing here is I'm taking 5 squared, so 5 to the second power times 5 to the second power, times 5 to the second power. And if I mapped that out even more, I could say 5 times itself 6 times, which does in fact simplify to 5 to the 6th power. Let's look at the middle column, 3 to the 5th over 3 to the 8th. I could use my strategies for dividing exponents with the same base, which say that if I have the same base and I'm dividing our powers, I could just take 3 raised to the 5 minus 8 power. That simplifies to 3 to the negative 3 power. And I can't leave my answer in that form because I've got a negative power, so I would want to write that as 1 over 3 cubed. That's one strategy for getting to my answer. Another strategy for getting to my answer would be to map out what happens when I multiply these bases over and over again. So my numerator has 3 to the 5th power, so that's 3 times itself, 5 times. I'm going to put times 1 so I don't forget that that doesn't change my value. In my denominator, I've got 3 times itself, 8 times. And again, times 1 so it doesn't change my value. And then if I look at what I can get rid of there, well, I've got 5 3s that appear in both the numerator and denominator. So I can cancel those out. So if I cancel those out, I'm left with 1 in my numerator and then 3 more 3s in my denominator and also a 1. So if I write out what this looks like in exponential form, in my numerator, I've got a 1, and in my denominator, I've got 3 to the 3rd power. So either way, I end up with 1 over 3 cubed. For 1 over 3 to the negative 19th power, what I'm doing is just taking that negative power and making it positive by switching it from the denominator to the numerator. As a reminder, anytime I have a base raised to a negative power, if it's in the numerator, I switch it to the denominator and make the power positive. And the reverse is also true. If my negative power starts out in the denominator, in order to make it positive, I just move it to the numerator and write it with a positive power.